Hello, algebra students. Mr. Lawrence here, and if you're watching this video, hopefully you're watching with one or two other people, not too many because it gets too big, but you're watching with one or two other people. You have your notebook ready to go, pencil or pen, right? You're going to pause this video off, and you're watching because you did really well on both parts of your test, all right? Some of your classmates need a little bit of instruction, need a little bit of help, no problem. We can't be successful unless they're learning too, so we're going to give them a chance to learn something and kind of step up to the plate. Anyway, you're watching this video with your couple people in your group, and what I need you to do is take some notes, try the practice problems I throw at you, and at the end you're gonna learn something that's gonna blow your mind, something you didn't know was possible. All right, now we're going to convert decimals to fractions. And remember, all fractions are rational. It is impossible to take an irrational number and convert it to a fraction. Can't do it, okay? We're going to start with terminating decimals. These are really easy to convert. So obviously, we're only dealing with rational numbers, right? Okay, so we're going to read this, and you know, Mr. Lawrence is a big stickler on not saying 0.75, right? This is 75/100ths. 75/100ths. Oh my goodness, I just converted the decimal to a fraction. Man, that was hard. Not. Okay, now, a good math student will also simplify their fraction. And let's see, I'm going to divide both the numerator and the denominator by the same number. I'm not going to grab 5. I'm going to grab the biggest number that is a common factor of 75 and 100. And there I just said it, it's 25. So I'm going to divide by 25, going to divide by 25, and I'm going to get 3/4. And most of you probably already knew 75/100ths was the same as 3/4. But there you go. That's the work for it. All right, let's try this one here. And actually, this is my second take on the video. I read this one right, and I wrote it incorrectly. All right, this is a 144 1,000ths. 144 1,000ths, right? And now I'm going to simplify. Now, I don't know the biggest number that goes into both my numerator and denominator as well as I did on the previous problem. But I do recognize that 4 is going into both of them. So I'm going to divide them both by 4. And I'll see where that leaves me. Perhaps I'll need to divide again. I'm suspecting 16 might go in, but I'm not positive about that. Well, if I cut 1,000 in half, I get 500. If I cut that in half, I get 250. Okay. And if I cut this in half, I get 72. And if I cut that in half, I'll get 36. So 144 over 1,000 is the same as 36 over 250. Now, I don't think 16 is going in, but I see I can divide by 2. I can divide by 2 here. So I'm going to divide by 2 in the numerator. And I'm going to divide by 2 in the denominator. By the way, did you know how I knew 16 wouldn't go in after seeing this first work? What's 4 times 4? Of course, 16. If I divide by 4, and then I divide by 4 again, I just divided by 16, whether I realize it or not. Now, I knew that 4 goes into 36, but 4 does not go into 250. Why? Because 4 doesn't go into 50. This trick only works for 4s. If you look at the last 2 digits, the 10s and 1s digits, and if 4 goes into that number, then 4 goes into the entire number. So does 4 go into 0? Sure, 0 times. 0 divided by 4 is 0. So therefore, 4 goes into 1,000. Does 4 go into 44? You bet. 11 times. Well, 144 can be divided by 4, right? So I knew 4 wasn't going to go into 250 because 4 doesn't go into 50, so I didn't try 4 again. All right, so I cut that in half. I get 18, and then I get 125. Oh, let me see here. 3's not going in. 6 can't go in because it's not even. 9 isn't going to go in. And 18, I don't believe so. So I'm pretty sure I am there. Now, you know, you can always check yourself. I'll grab a calculator, and I can bring my calculator up, but I'm not going to. I'm just typing in 18 divided by 125 on my calculator. Sure enough, I get 144 1,000ths. And then I'm going to hit the math frac button, and it converts it to its smallest decimal. Ask me about that if you don't know what I'm talking about. It's on the graphing calculators. And it turns it into 18 over 125, which is what I'm suggesting. All right, so that's pretty simple stuff. Now here's the magic stuff. This is really cool stuff. And my non-algebra kids, my algebra-like kids can already do this. Why? Because they've been taught. We're going to turn 6/10 repeating into a fraction. Now this is so cool. The first thing we're going to do is get my airliner to work. We're going to let n, make sure you take these notes, n equal 0 and 6/10 repeating. Now, I'm going to look and see how many digits it takes before I repeat. Well, here just the 10th digit repeats, right? So I'm going to multiply by 10. I'm going to do it on both sides of the equation. So when I multiply this by 10, isn't it going to turn into 6 and 6/10 repeating, right? Like when I multiply 2.5 times 10, sorry, that's multiplication. Don't I get 25? Right? If you're using the trick that, oh, you just add a 0 when you multiply by 10. Forget it. You're wrong. It's not true. The decimal point does move one to the right, though. 2.5 becomes 25, right? If I take 33 and 86 1/100ths and I multiply by 10, that decimal point is going to move one place, and I'm going to get 338 and 6/10. Okay, by the way, dividing by 10 would take it the other way. Now watch, this is really cool. So I multiplied by 10, and I've got this equation now, right? I'm going to take my original equation, and I'm going to subtract it from the first equation. Now, please don't give Mr. Lawrence a heart attack. Please don't tell him that 10n minus n is 10. This is multiplication. That's subtraction. They don't undo each other. Look, if you have to, I don't like it, but if you have to, sneak that little 1 in there, okay? Because -1n and -n are the same thing. And when you do 10n minus 1n, don't you get 9n? And over on the right-hand side, these will cancel out, and you'll be left with a plain old 6. Well, now I can get n alone, solving a one-step equation, and then n is going to equal 6/9, but a better answer would be to simplify and get 2/3. What that means is 0 and 6/10 repeating is equal to 2/3. They're the same number. Yeah, just two different ways to express the same number. Okay, let's try this one here. Whoa, get back there. Get back. Back, I say. It's not listening. Okay, this problem is very much the same thing. We're going to let n equal 18/100ths repeating. Now, in this problem, I have, it's repeating in the hundredths place. So I'm not going to multiply by 10, I'm going to multiply by 100. 100n. And when I multiply the right-hand side by 100n, that's going to cause the decimal point to move two places. So one, I get 18 and 18/100ths repeating. Now I subtract the original equation from the first, and I tell you, I will cry if you tell me that 100n minus n is 100. It makes no sense. If I have 100 noodles and I eat one of them, I have 99 noodles left, right? Not right, correct. And that's going to equal 18 because those canceled out. All right, so now I divide by 99. 99 Luftballons. Ask your parents. They might know what I'm talking about, although they're probably getting a little bit young to know what I mean. All right, so n is going to equal, let me see, I can simplify that. I'm going to divide by 9 and divide by 9, and I believe I'm going to get 2/11ths. 2/11ths is the same as 18/100ths repeating. You don't believe me? Pull out your calculator and divide 2 by 11. Now you should be pausing as you go, okay? So anytime you want to, anybody in the group wants to pause, you go ahead. All right, so let's try this one. One more example. So I'm going to let n equal 126 1,000ths repeating. I'm going to multiply by, what's that? You got it, 1,000 on both sides. The decimal point is going to move 1, to 3 places. Woo, look at me. And then the repeating decimal will be left. If you don't get that, remember, 1 in 2600 repeating is like this, right? And that just keeps going forever and ever. If I take that decimal point and I move it 1, 2, 3 places, don't I get 126 and 126 1,000ths repeating? Now, you do your subtraction, and you're going to subtract. Okay. And so I'm going to get 999 n equals 126. All right. I'm going to divide by 999 on both sides. So now I'm going to do some simplifying. I like simplifying. I'm good at it. I know that 9's going in here. I also know 9's going in here. How do I know? Because 1 plus 2 plus 6 is 9. If the digits of the number add up to be 9, you can divide by 9. That trick only works for 3's and 9's. All right, so my denominator becomes 111. The numerator, let's see if I can do this in my head, is going to go in 14 times. And there you go, 14 111ths. I feel pretty smart now, I hope, because it's pretty easy to do. Like I said, my Algebra Light kids can do this. All right, I want you to try 4 and 5. Pause the video. Try them on your own. You can talk to each other as you do it, okay? And then when you're ready, listen for my answer, okay? Okay, if your video's still playing, it means you've already tried them and you know the answers. And I'm going to tell you that 0 and 4/10 repeating is the same as 4/9. All right, if you did not get 4/9, you've done something wrong. Go back and check your work. Okay, I'm getting ready to tell you the answer for number 5. Please make sure you've already done it. If you haven't, go back and do it, you silly goose. All right, 3600ths repeating is going to be 4/11. That's just a coincidence that both numerators were 4. Okay, I just picked some easy numbers. Now, in your group, I want you to try it with 9/10 repeating and see what happens. It will blow your mind. All right, that's it for the video. You can get started on the worksheet. Yeah, Mr. Lawrence signing off. Have a good night, everybody.